Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, GEMS Engineering Management Technical Campus, Knowledge Park 3, Greater Noida. The subject that I teach in this semester for BTech 7th semester students of electronics background is optoelectronics and optical communication, and the topic that I discuss in this video lecture is optical detectors and fiber optic receivers. So, okay, we already familiar or know the function or the operation of fiber optic transmitter. I once again, uh, have some brief description of this. The operation of a fiber optic transmitter is that it is an electro-optic device capable of accepting electrical signals, converting them into optical signal, and launching the optical signals into an optical fiber. So basically, the operation of optical transmitter, of course, optical source is one of the important part of that. Is that optical transmitter accept electrical signal as at its input and gives a light signal at its output, and one of the important device that used for that purpose in transmitter is optical source, whether it is laser or it may be LED. So basically this is the function of optical transmitter. Now the signal that is the output of the optical transmitter is launched into the optical fiber, and through optical fiber it will reach at optical receiver. So optical receiver receive that light signal at its input, and the function of receiver is the reverse as that of transmitter. Means receiver accept optical signals and gives electrical signal at its output. And optical detector is one of the important part of optical receiver, same as optical source in optical transmitter. And the function of optical detector is reverse the function of optical source. Means optical detector convert optical signal into electrical signal, or you may say optical signal into equivalent electrical signal, right? So optical detector is the main part of optical receiver, and the performance of optical receiver actually depends upon the performance of optical detector. Okay, apart from optical detector, many other devices are also included in optical receiver that gives process the output of the optical detector, which is a current, because we need amplification, because the output of the optical detector, of course it's a current, but it's a very weak signal, so we need amplification too. So for that we need amplifier. So amplify that the output of the optical detector at such a level so that the processing can be done of that, and we get the final output at the receiver, right? So the optical signals propagating in a fiber become weakened and distorted because of scattering, absorption, and dispersion. So when the signal that you launched from optical transmitter into the optical fiber at the transmitter side, now that signal propagate through optical fiber, and the tendency of optical signal or any other signal is that the signal is decay with the distance, mean decay in the power, decay in the energy with the distance. This is a tendency, and the reason we is that because of the loss. So the amplitude or voltage level of the signal decreases, and the reason, as far as the optical signal into the fiber is concerned, we have a phenomena of scattering, absorption, dispersion. All three phenomena are come in the category of loss, and due to that, the signal that is reached at the receiver side, or the input of the optical receiver, so receiver or you must say optical detector, is very weak, right? Because of the losses come in the picture when the signal propagate through the optical fiber. So The fiber optic device responsible for converting the weakened or the weak and distorted optical signal back to an electrical signal is a fiber optic receiver. So fiber optic receiver, or the you must say optical receiver, convert this very weak and distorted optical signal back to the electrical signal, right? This is the duty, or this is the main function of the optical detector in optical receiver. So the fiber optic receiver is an electro-optic device, or you must say optoelectronic device, that accept optical signals from an optical fiber and converts them into electrical signals. So a typical fiber optic receiver consists of an optical detector, a low noise amplifier, and other circuit used to produce the output electrical signal. So apart from optical detector, of course, is a very important part of the optical receiver. We need another devices like low noise amplifier, because we need amplification, and other other circuits that are used for signal processing. Maybe filters, maybe other devices are used to produce the final output electrical signal, right? So the optical detector converts the incoming optical signal into an electrical signal. This is the basic function of optical detector in optical receiver, to convert incoming optical signal into an electrical signal, and this electrical signal is very weak, so need amplification. After that, we have amplifiers, so that the gain should be added in the signal, so the signal become little bit strong, to get some to get to get the signal processing unit to do some work on that and give the final output at the optical receiver, of course, which is a current, right? So this is the basically diagram. You have optical input. This is the this is your optical input coming from the optical fiber. This is optical detector. Here is the conversions take place. Here is the light, and here is the weak current. Need amplification. So this is a strong current, strong voltage, strong signal, and this is the processing unit, and this is your final electrical output. So in this way, this particular, this is a block diagram of optical receiver, where optical detector is the main part. So the amplifier that amplifies the electrical signal to a level suitable for further signal processing. So the type of other circuitry contained within the receiver depends on what type of modulation is used and receiver electrical output requirement. So receiver spectral response, sensitivity, frequency response, and dynamic range are key receiver performance parameters that can affect overall system operation. The meaning is that the overall operation of the receiver actually depends upon few factors, like receiver spectral response means the receiver output have all the frequency components that the current that the signal have at the transmitter side. So all the frequency components should be retrieved at the receiver side. So this is the receiver spectral response. And then sensitivity, the signal is very big, so the sensitivity means it's the amount of power that need to a receiver to give a result at its output in the form of current. So if the sensitivity of the receiver is high, means it can sense very weak signal in the form of light and give its output. So this is the sensitivity. And frequency response. And dynamic range means minimum to maximum optical power that the particular receiver can handle or can give the result. So these are the key receiver performance parameters that can affect the overall system operation. And the choice of optical detector materials and structure determines the spectral response. So spectral response of the optical detector depends on the material and structure. Basically, silicon, gallium arsenide, and gallium aluminum arsenide are typical detector materials used for receiver operation in 850 nanometer wavelength window or region. And germanium, indium phosphide, INP, and indium gallium arsenide INGAS are example of detector materials used for receiver operation in the 1300 nanometer and 1550 nanometer wavelength region. So the receiver sensitivity that we talked about that in previous slide. So the receiver sensitivity, how we define the receiver sensitivity. So the receiver sensitivity is the minimum amount of optical power required to achieve a specific receiver performance, right? So it is a minimum amount of power that the particular receiver can perform, can give the result that I said in the previous slides. So this is the basically definition of receiver sensitivity. So for digital transmission at a given data rate and coding, this performance is described by a maximum bit rate. Then bit error rate. Sorry, bit error rate is the bit error rate is the number of bits that are wrongly indicated by this receiver with the total number of bits the receiver received. Right. So if the receiver received 1000 bits and and gives and gives 10 and gives error in 10 bits, the 10 upon 1000 is a bit error rate, is it? So the error number, or you may say the bits that have a number that have that incorrect bits upon total number of bits that particular receiver received. So in analog systems, for a given modulation and bandwidth, it is described by a minimum signal to noise ratio. So there are two terms for which any receiver performance can be measured on the basis of bit error rate and the basis of SNR, signal to noise ratio. So if your signal to noise ratio is high, then obviously a bit error rate is minimum, means less number of bits are read incorrect by the receiver. This is the meaning. So bit error rate and signal to noise ratio are the two very important factors that gives the performance of any receiver, or you may say the performance of any receiver judged on the basis of two factors, which is bit error rate and signal to noise ratio. Come to the dynamic range. Dynamic range refers to the range of optical power levels over which the receiver operates within the specified value. So dynamic range means it's the range of optical power over which the receiver operates satisfactory or within a specified values. So it usually is described by the ratio of maximum input power to the sensitivity. So these are certain factors that we discuss in this slide, that on the basis of that we can judge the performance of optical receiver, right? So these are some factors. So that optical detector and optical receiver, is very important as far as syllabus is concerned, and many times the questions asked in examination, by suitable diagram, explain the block diagram of optical receiver, or sometime what is the function of optical detector, and sometime question may be asked in optical receiver or in optical detector, define the term sensitivity, dynamic range, bit error rate, S by N ratio. So sometimes these are the questions that can be asked in the examination, right? So a student should prepare all the terms when go through this topic, optical receiver or optical detectors, right? So this is very important for the students. So student should prepare this topic well, right? So that's all for this. So thank you very much.